Okay, so shall we begin? Okay, able to see the PDF? Okay, able to see the PDF?
Yes, sir.
Okay, so let us, if there is any thing, just let me know here. Okay, so let us begin with the part 2 here of module 2. Usually, the first part of the module is concerned with what we can say that microwave network theory here. Okay, first part is concerned with the microwave network theory here. We are trying to understand how exactly the microwave network is there, and what and all the voltage current relationship is there, and how exactly we're going to find out his voltage and current relationship here, and also other parameters we are going to discuss in the first part of the second module here. The second part is very easier to understand here. We are trying to understand the devices here. Okay, devices of the microwave here. Okay, over that also microwave passive devices we are trying to understand here. Okay, so what is exactly the definition of this microwave devices is, or microwave passive devices is there. Here we, somebody is joining here. Okay, microwave or passive devices or the components are there, no? So usually, how exactly these have been designed here? Usually, these have been designed taking some part of the microwave coaxial line, or what you can say that the waveguides here, or the strip lines here, or microwave strip lines here. Okay, so these are used in the laboratory and also the microwave radar communications here. Okay, this is how you can say that microwave passive devices and components have been designed here. Okay, taking the part of the coaxial line or the waveguide or the strip lines or microwave here, you are able to design the microwave passive devices here. Now, so usually these devices will be having either one port or a multi-port here. Okay, either we will be having a single port or two port or three port here, based on whatever the requirement or application is there, it will be designed here. So what we are trying to understand here is we are trying to characterize this multi-port or single port here with some characteristics here. Okay, like we are having VSWR. We have learned in the first module, no? VSWR, that is voltage standing wave ratio, will be defined for this particular three port or two port network or one port network. There is something called as a reflection coefficient. This is also nothing but here kind of a parameter here, which is going to characterize our two port or three port or one port microwave passive devices here. Okay, so now there are also certain losses here, which have been mentioned in the module 2 part 1 here. There are nothing but here insertion losses. Whenever we try to pass the signal here, or whenever we try to insert the signal here in a particular component here, what is the loss we are having here? Whether we are trying to insert the 100% signal strength or 100% energy or not here, there will be certain loss will be there here. Okay, while transmitting or while inserting the energy into a particular component here, component or a devices here. Okay, that is what is insertion loss we can call it as. There is something called transmission loss here. Transmission loss here. Transmission loss is nothing but here again. You will be having certain transmission power. Let us assume that 10 kilowatt is the transmission power here. Sorry, transmitted power here. Okay, there will be certain power which is lost in the transmission here, or certain power will be there which will be reflected back here. So how much exactly the power will be transmitted and how much exactly the transmission will be lost here, that is also will come to know with the help of a transmission line here. Okay, and there is another one, something called as reflection losses there. Okay, how much of the transmitted wave is reflected back to the source here, how much we have transmitted from the source here, and how much has been reflected here, reflection loss it is called as. And something called as return loss, how much has been returned here. Okay, reflected divided by the incident here. Okay, these are all the, what you can say that parameters are there here. Whenever we talk about the microwave passive devices here, there are certain parameters like VSWR, reflection coefficient, which describe or characterize the microwave network, one port, two port, three port, multi-port networks here. There are certain losses also here: insertion loss, transmission loss, reflection loss, and return loss here. Now, what we are going to discuss here is that we are going to discuss only the four microwave passive devices here. Okay, so what are those four microwave passive devices? First one is coaxial connectors are there here, and second one is attenuators here, third one is phase shifters here, and fourth one is a waveguide T's here. Okay, so these are the four devices here which we are going to discuss in the whole this particular chapter here. Okay, right. So everybody is clear with this particular basic introduction here. Yes or no?
Yes, sir.
Okay, fine then. So let us begin with first our device here, that is coaxial connectors here. You are able to see the movement of the PDF file here. Hello, hello, hello. Chidambar, Vidyashri, Rashmi, Sushmita, Nitin. Can anybody reply here? You are able to see the movement of the PDF here.
Yes, sir.
Yes, sir. Okay, mouse movement, mouse movement.
Yes, sir.
Okay. Okay, so we are going to discuss the four microwave passive devices here in detail. We are having certain metrics to be find out here. Okay. Out of these four microwave passive devices here, waveguide T's are very important here. Many times this has been asked. That is nothing but the fourth component here, or fourth device is here, like microwave T's. Okay, these are waveguide T's has been asked many a times in the examinations here. So. The first one, before getting into this coaxial connectors here, what is exactly this coaxial cable here? You try to understand. Okay, what is exactly the coaxial cable, or at least the coaxial cable introduction we need to understand here. So there are many microwave components are there here, and also there are many microwave devices are there here. So usually, whenever we try to connect these microwave components or microwave devices here, you need a coaxial cable here, right? Okay, to connect the microwave devices or the microwave components here, you need a coaxial cable here. Okay, so coaxial cables usually of particular length they are going to be selected here, and every individual coaxial cable is going to operate with the different frequencies here. Remember, okay. So based on the component microwave component requirement or the microwave devices requirement here, coaxial cable of suitable length will be selected, and it will be used for those connection of the microwave devices or microwave components here. Okay, and remember here in this, I think you people are very much aware of the TE mode. Okay, transverse electronic mode and transverse magnetic mode and transverse electromagnetic mode, TE mode, TM mode, and TEM mode here, right? So usually in the coaxial cable line here, TEM mode is used here. Okay, remember TEM mode is used, or TEM mode is propagated through the coaxial cable line here. Okay, what about the impedance that has been offered by the coaxial cable here? Either there is a 50 ohm impedance is offered, or 75 ohm impedance is offered here. Okay, so and again there is a classification of the coaxial cables here. There are three kinds of coaxial cables here. Fixed coaxial cables are there, semi-rigid coaxial cable are there, and rigid kind of a coaxial cable are there. Okay, so these are just introduction concerned with the coaxial cable here. Okay, coaxial cable are utilized in the connection of microwave components or microwave devices here, right? So there are three kinds: flexible, semi-rigid, and rigid here. Okay, based on the applications here, we try to use the flexible coaxial cable or semi-rigid coaxial cable or rigid coaxial cable here, right? Now let us understand, this was the brief of a coaxial cable here. Now what are we trying to understand is coaxial connectors here, right? Coaxial connectors here. So coaxial cables, usually what we do is either it is being terminated here, coaxial cables, it has to be terminated here, or it has to be connected with another device here, right? Or any kind of a micro component here. So how exactly we are going to connect those things here? With the help of a coaxial connectors, it is called as. Okay, coaxial connectors, or you can say that shielded standard connectors, they are also called as. Okay, you can see in this PDF here, shielded standard connectors here. Okay, now Usually this the circumference of the coaxial cable is there, no, it is limited for only high frequencies here, as it is having only the one microwave length here. Okay, one microwave length will be there here. That's why the circumference, that's why it is being able to operate at a high frequency here. Okay, and why this limitation is necessary here? Okay. The limitation is necessary because, see, there are usually, whenever there is some kind of a cable is there or the signal has been transmitted, no, there is always some kind of a distortion will be there, or there is some kind of a losses will be there in terms of a power, or there is a reflection coefficient is there, or transmission loss is there. These are all things will be there. Hence, to limit all these kind of an what you can say that losses, no? So that's why what they did here is the average circumference of the coaxial cable is maintained as one wavelength here, or one lambda here. Okay, for fine frequency operation, and also to limit all these things or eliminate all these things, reflection coefficient or signal distortion and power losses here. Okay, there are many kind of connectors are there here. Okay, there are around 5 to 6 connectors are there here. Okay, so depending on how they have been classified is depending on the particular frequency range here. Okay, depending on the particular frequency range, these connectors have been classified here. For example, let us consider the first one which we have, which you can see here. It is type N here. Type N. Okay, so type N is connector is there here. Type N connector is there. No? So this type N connector usually, okay, so it is impedance will be around 50 to what you can say that 75 here. You can just see here 50 to 75 here. Someone is trying to join here. Okay, right. So what is exactly the impedance that is being offered by the type N here? Navy connector. It is type N is nothing but here N stands for Navy connector here. So it is impedance offered by is either 50 ohm they offer here or 75 ohm here. What is the frequency range it is going to operate in? 18 gigahertz frequency it is going to operate here. Okay, so now another point which I wanted to mention here is low. It is having the very low VSWR. VSWR is something like a voltage standing wave ratio here. Okay, this one, when exactly this voltage standing wave ratio comes into picture here, when exactly this comes into picture, I think you have learned in the first module reflection oscillator here. Whenever there is more reflection is there here, okay, from the load side here. Okay, remember, whenever there is a reflection is there from the load side here, so what happens here, the waves are going to coincide and they form the voltage standing wave ratio. Lesser the voltage standing wave ratio, better the transmission of the signal from one place to another place here. No reflection means there is a 100% transmission of a signal from source to destination here. That's why he has mentioned that this type N connector is having a very low VSWR. Okay, so remember here these types of connectors have been developed here. When they have developed during the World War II here, that is between 1940 to 1945 here. Okay, another one is the BNC. What is BNC here? Bayonet Navy connector here. And this is also developed during the World War II here. Usually there is a first coaxial cable I mentioned here, right? Flexible coaxial cable, one type of a first type of a coaxial cable. Usually these BNCs are used with the first type of a flexible coaxial cable here. Again, it is having an impedance of 50 ohm to 75 ohm. It is going to operate with the 4 gigahertz here, right? BNC, I think you have seen in your lab also here. Okay, LIC, AC plus LIC lab also we are able to see all these components here, BNC, SMA, and all these components which I have mentioned, no, connectors. These are all available in our laboratory here. Whenever you are free or when we come to the college here, you are able to see all these things in our lab here. Okay. Now, third one is the TNC. TNC is nothing but threaded navy connector here. Okay, these are also nothing but here again. It is going to operate with the 50 to 75 ohm here. Okay, and again it is at 12 gigahertz here, just above the is the second on BNC here. Usually TNC is considered as the improved version of the BNC here. Okay, there was certain radiation loss here. What it is? Radiation loss at high frequencies at the BNC here. Okay, that's why that radiation loss is prevented, okay, at high frequencies here in the TNC here, threaded navy connector. That's why it is able to operate at 12 gigahertz here, okay, but rather than the BNE, which is BNC, which is going to operate at only 4 gigahertz here, right? Okay, next one is SMA. SMA is nothing but here sub miniature A here, sub miniature A is, okay. This is also again another kind of an connector here, coaxial connector here, which is going to operate only at a 50 ohms here. Impedance is offered as 50 ohms, but it is one of the, what you can say that it is going to operate at 24 gigahertz here. Okay, second highest. Okay, okay, second highest. Frequency range is having 24 gigahertz here, right? And another two are there here, right? APC is nothing but uh, phenol phenol Prussian connector here. Okay, this is there it is again 7 mm or 3.5 mm, two are there here. Okay, based on what you can say that 7 mm APC is there, no, phenol Western connector is there 7 mm, which is having very low VSWR here, and hence and also it is having a 50 ohm impedance here, and it is going to operate 18 gigahertz here, right? Why there is a 3.5 mm APC is there is because it is having extremely low, very low what you can say the VSWR, voltage standing wave ratio. That is nothing but here we don't have any kind of reflection at all here. Okay, we don't have any kind of reflection, and hence it is going to operate at the range of 34 gigahertz here. Okay, so highest, okay, highest what you can say, there will be no loss here. If we try to use this kind of a connector between the two cables or any kind of microwave equipment here. Okay, so this is what is the coaxial cable connector here. Okay, remember this much you have to write here whenever we try to ask you the question regarding the coaxial cable connectors here. You have to mention all these points here, 3 points, and you mention the types of connectors we are having, and corresponding whatever the impedances, frequency range is there, what kind of a dielectric material they are using here. Some are air and some are solid here, and some can be used as a both male and female. Some are neutral here. So these all have to be mentioned here. Let us understand another one is that is adapter. So you can see these are the, you can see in the figure here, these are the kind of cable connectors here. These are also available in our microwave lab or advanced communication lab here. These you can see physically in our lab here. Once you visit the college, you can always examine these things also here. Okay, let us understand another point here, that is attenuators here, or you can say adapters here. Just one point is that adapters here. So these are nothing but here usually these are connected to the two ends of the connector here. That is either coaxial cable or this connectors here. Their adapters are connected here. So for it is usually utilized for the interconnection of the two different microwave ports here. So they try to excite dominant mode inside the rectangular waveguide here. Okay, so using this dominant mode here, what we are going to get here, something called as a there will be no phase cancellation will be there here, there will be maximum power transmitted will be there here, and whatever the impedances is there, no, if at all we have a purely resistive kind of a thing, no, then it is very easier for us to transmit the microwave signal from one place to another place here. Okay, so these adapters are utilized for transmitting maximum power here, and also we try to teach the have the impedance completely of a resistive kind of a thing here. Okay, purely resistive here. This can be achieved through the coupling probe here, right? Okay, so this is what is the adapter here. Just a small one line, two line statement you can make it out.